Let us then start today's session. So let me share my screen. So do you have any particular, before sharing my screen, do you have any particular doubts from the lecture session held by Professor Datta?
No, no, sir.
No. Again, you are calling me, sir, you are elder
Okay.
than me.
Sorry, no, no.
Yeah. Okay, okay. So I'll just go to my presentation slide and you know this thing. So I'll go to the so I have gathered a few numerical problems from Macquarie and Simon's physical chemistry book for the quantum, and I have got a few, and we are just solving them a few questions just to brush up the numerical problems solving ability or something like that. So I am also going to do this problem for the first time, so I may also make some mistakes. I will need your help uh, to pointing out those mistakes. Okay? So let us start. So the first question says calculate the uncertainty in x and x square, not uncertainty, the mean values of x, right? The average value of position and this position square, the average of that for the n is equal to 2 state for a particle in a 1D box. So can you tell me how can we approach this problem? What should be the first approach for this kind of problem? And we need to show that the uncertainty or the standard deviation in x or the position is uh, this particular expression. So we need to go on that. So the we know that uncertainty in x or the standard deviation will be, I think, the square root of, so this is uncertainty, and variance is sigma x whole square, right? So that is related to what I remember, it is something like x square, right? Or the reverse. I forgot actually, which is true. Um, Now, do you remember which one is true? That if it is x square or minus x square. So I'll quickly go back to our previous uh, discussion. So let us first do this. We'll understand that if it is the what is it. So we can understand that we need these two things, right? The average value of x square and average value of x. So it would be something like x square minus x. So this is the average value for x square and this is the average value for x. So these two things are different, right? So how to calculate the average uh, value of momentum for a particle in a box? Is it dependent on the in state? So anyway, I will just quickly brush up the thing that what does this? How can we calculate this for a normalized state? We can for any
I'm
size.
feeling lost because I've not been able to revise what is done. So I'm little feeling lost today. Like,
Okay, so you do you remember that what is the how to calculate? So what do you remember particle in a box problem?
yes, yes, yes. I'll just go through the pages. I'll just turn the book and see.
Okay, so the wave function for a particle in a box after solving the Schrodinger equation we'll get something like that root over 2 by L sine function of n by
Yes, yes.
x by L, where L is the length of that box and n is the quantum number, and we are just doing it in the one-dimensional box, one-dimensional thing, that is the x-axis. And it is also important that we should remember we can use this sine function or this wave function
Mm,
when the box is starting from 0 to L. Okay, today
yes.
we'll solve one problem where the box will be where we will take the box from minus A to A. So we'll see what will happen to the wave functions. But
Okay.
before that, we should also remember that we should remember the boundaries, that what boundary we are solving. So for 0 to L, when we are solving for this particular case, we'll get something like psi n, something like root over 2 by L, sine n by x by L.
Yes.
Now, from the quantum mechanical postulates, whatever the some few postulates are there, so there was one postulate for the measurement theory. So from there, we have learned that for any average value, so this is known as the average value for x, or and this is x square is that inside this kind of bracket, this means that it is we are going to calculate an average value, or average value, or it is also known as expectation value. So it could be known as a lot of things, expectations value. So in exam or in books, it could be written anything like this: average value, expectation value, something like this. Okay. So, so this will come as psi n x, your operator. So this is an operator, right? This is momentum operator, and this is momentum operator and square of that. And it will be something psi n inside a bracket function divided by your psi n inside the bracket. So when you're so this wave function what we have written is already normalized, right? Because the normalization constant is root over 2 by n. I hope you remember this. Priyanka, do you remember that? That
Yes,
this
yes,
is the
yes,
normalization.
yes, yes,
So
yes,
we don't need to calculate the denominator because it is already
yes,
one. Because from
yes.
there we will get something like that. So for this, so first we'll calculate for psi of psi n for any n. We'll see if the value is dependent on n or not. Okay. So let's see what we will get. So we'll get okay. Okay. Uh, I can take 2 by L outside, right? Because there will be 2 root 2 by L. So we can take 2 by L, because root 2 by L into root 2 by L, those will be in that is a real quantity, and root 2 by L into root 2 by L is 2 by L. So inside, and that is also outside the integration, because that is a constant, that is not something uh, x dependent variable, right? And now here, why I have mentioned the boundary here at beginning, because when we are going to do an integration, we'll need this integration limits. So that is why I put the value 0 to l, right? So what we can see that, so what does this mean? So this portion means psi n star, integration psi n star. So psi n star, if we see that complex conjugate of sine function is that, because this is a real function, so there will be no change. So again, this will be sine n pi x by L, right? Then there is our operator x, and then again it is operating on the n pi x, sine n pi x by L, and dx is there. So it will be a little easy that right now, and there is no denominator or one. So it will be something x sine square n pi x by L dx. So, and uh, okay, let us go step by step. I could have tell you what will be the solution, but as you are here to brush up your some of the, at least some of the integration we should do here, because else when you are solving your problem you may find some problem. So let us solve this solve this integration. I hope we'll be able to do this later. But so do you know how can we solve this integration? Because as you can see, there are two terms in x, right? One is x, and another is sine square n pi x by L. So you'll actually use a integration solution called integration by parts.
Parts.
So
U
yeah,
into V, that thing, that
yes,
formula. Yeah.
yes. So there could be so there are numerical way that that thing is written in the internet. If you find that, if you search for integration by parts, a lot of thing may come. So what I generally use, so suppose if u and v and it is, they are dependent on x, they are function of x. So I generally do that, I take u outside. So the formula I use that is u v dx. So we can write it in a couple of kinds of way. But I use this particular way. So then there is another integration minus integration of du by dx, then another integration under the integration. So I can use another bracket actually. So second bracket, then again v dx, then my bracket close, and then this integration is there. So I will use this particular formula to solve this. So where u and v are x dependent. Okay. So here I will take u as x and v as sine square n pi x by l, because I can see that there is a term du by dx. So I need to means means if I take sine square n pi x by l as u, then you will see that that will lead to 2 sine n pi x by l and cos n pi x by l. I know I may sound a little means complicated, but the thing is, what I'm trying to say that to solve this problem, we will use u as x and we will take the sine square term as v. So let us see what we will get. So you are familiar with this. What I am doing means, do I need to go in deep, or can I just quickly solve the integration?
No,
What do you think?
we can quickly solve the integration.
Okay, 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 okay. We'll quickly do that. So 0 to L. So I'll not. Acha, let us do that. I'll just quickly erase this thing. Okay. So x here, integration of sine square n pi x by L dx minus, I'll take it as minus du by dx, means here dx by dx will be 1, and then again sine square n pi x by L dx and bracket close, and here it is 0 to L, 0 to L, and I have done one mistake, that there is another dx still there also. Okay, so here it is also 0 to L. So I will take this 2 inside. So my x will sine it will become 2 sine square n pi x. 2 sine square n pi x is equivalent to our cos 2 n pi x by L uh, minus 1, I guess. I will quickly check. So I generally forget this. This cos 2 theta is cos square theta minus sine square theta, right? So this is nothing but 1 minus 2 sine square theta. So sine 2 sine square theta is 2 sine square theta is 1 minus cos 2 theta. So I have done one mistake. It will be plus 1 and this will be minus. So what we'll get here, I will quickly write 1 minus cos 2 n pi x by L dx minus 0 to L. I'll have still have one more integration, right? 0 to L. Uh, that is again 1 minus cos 2 n pi x by L dx. Then another dx is still there. So 1 by L x, and then um, 0 to L. Achha, I'll just right now I'll just solve it. Integration, I'll do this integration. It will be x into x minus, what is the integration of cos 2 n pi x by L? It will be L 2 n pi sine 2 n pi x by L. Okay, this is L to 0, and here we have 0 to L 1 minus L by 2n pi sine 2n pi x by L dx. So we have done this integration and another integration is still left. Okay, for this part. So I will how to do the next part. I need this thing. So I'll just can you see if I write here? If I write here 1 by
Yes,
L.
yes, yes,
Okay,
yes.
okay. So it will be acha, I think I should not I should take this x also inside because when we do integration by parts, I should write this 0 L. I can write it later actually. You will see this will be beneficial if I write these points outside. What I meant by that is I'll just write it here. Or you can say that you are doing an integration, just a normal integration outside, and then you are coming back to your main equation and putting those value, and you will put the limits. So it will be something x square minus xl by 2n pi sine sine 2n pi x by L minus, here I have to do another integration, right? So that would be minus 1 minus, so this will come as x, then so minus is still there and minus is here, so it will be plus L by 2n pi, but I'll have to do integration of this sign, so and there is 2n pi by L is still inside, so I'll get some constant like this, so L square L by 2n pi I will get again multiply by this, so I'll have this, and integration of sine will give me minus cos 2n pi x by L. Okay, and whole under the, and there is L to 0. Now I'll put this thing into perspective. So I'll just quickly remove some of the things so that solve um, I can solve it here. I have very less space and my writings are going upward. Just quickly, I can quickly remove this thing. I will come back to this later, right? Why I can't remove this? Okay, I'll just write it there. You let me know if I am making any mistake. Are you doing the problem yourself?
Yeah, I'm doing with you.
Okay, okay, okay. So x square will be L square, right? L square minus again L, x is L. So I'm just putting the limit first and by sine. We'll see if I put L here, so we'll get sine 2n pi. So I do not need to do much with this because you know that for any value of any integer value of n, because we already know n is integer, right? It will start from 1 to n by whatever infinity. So it will be a positive integer. So for any integer value of n, so sine 2n pi is always 0. So in the next step we will make it 0. And there is again x is there which is L, and then we have what do we have? Acha, we have plus, acha, this plus and minus is there, so it will be minus L by 2n pi whole square minus cos 2n pi. Now minus sign we have already taken care of, so cos 2n pi, and then we have to do for the 0, right? So we'll again come back and we'll add 0 square plus 0 anyway because x is there, so it will become 0, so I don't have to bother about sign 0 anyway. So again, so plus 0, then minus L by 2n pi whole square, no, minus cos 0 it will come as, right? It will come as cos 0, 2n pi into cos 0, sorry, and now my bracket will be closed. So what did I get? 1 by L. I'm very fearful that if I have made the correct thing or not. L square minus, so it is 0, minus L minus uh, L by 2n pi. Achha, cos 2n pi. What is the value of cos 2n pi? For any integer value of n, so it will be something cos, for n is equal to 1, it is cos 2 pi. For n equals to 2, it will be cos 4 pi. So you can understand that cos 2 pi will be, cos 2n pi will be always 1 for any integer value. So I'll just take a square of that and I'll not do anything. And then what we have here, that we have, again we have L by 2n pi. I think I have made some mistake. I'll quickly have to see that did I perform the mistake. So okay, so here I was putting the value of L, right, is 0. So minus, so already was there, so minus minus plus should be there, sorry, minus minus plus should be there right here, because this was for the L. So I'll do 0 square plus 0, and here it was already minus L by 2n pi square, that thing was there, so it should be a plus L by 2n pi, that square into cos 0, so that will cut. Okay, still I'm making some mistake because the answer I know, I remember that should come as L by 2, which is the finding the probability average value of x for a particle in a box. So where did I go wrong? Can you help me finding out? 2 by L. Oh, I have done some mistake. X is x sine square 25. So 2 sine square into, can I do the calculation freshly once? What do you think? Should I go ahead
So
on?
what?
Can I do
Just
this yeah. Can you point
there
out
was
if I?
two by L outside the bracket. No, then we wrote 1 by L somewhere.
Yes, here
This
because I took is as 2 sine square n pi x. I take it as 2 sine in square 2 sine square n
yeah,
pi
yeah,
x by L, because I wanted to convert it in terms of cos theta,
cos.
because you know that 2 sine square theta is 1 minus
One
cos 2
minus
theta.
cos 2 theta.
So it will be easier to do the integration with that. So I have done that in this step, that 1 by L x
Hmm.
integration of 1 minus cos 2 theta, something like this, dx minus integration. I'm just quickly recapitulating where could I have done the mistake. Uh, into 1 into this 1 minus cos 2n pi x by L dx L to 0 or 0 to L. Now the next step, 1 by L x, integration of this is x L by 2n pi sine 2n pi x by L up to this part is fine, minus integration. This integration is still there. The first integration that is still there, and we are doing an integration for the inner integration. What we are doing, so that is acha. I have done a mistake here because integration of 1 is x, that I didn't. So did you get my, where did I make the error? Did you get it?
Yes,
Because
yes.
I
Integration of
didn't.
one. Yeah.
Yes, that I have not done. So if I have done that, then it would have been x square, and then integration of that in the next step. I'll still go step by step because I could have made any make other mistake also. L by 2n pi and sine 2n by x, up to this part it is fine till now. Now there again 1 by L. Now this is x square because x was there outside, right? X square x L 2n pi sine 2n pi x by L, up to this part is fine because there is no more integration is there. I have just multiplied this x, that's why it is x and this x and a. And in the second part, it is now minus of integration of x, that is x square by 2, right? Then plus I took because minus and minus it is plus. L 2n pi is there, and from integration of sine 2n pi x by L, I will again get some constant that is L by 2n pi. So I have made a square of that, and integration of sine is minus cos 2n pi x by L, and up to this part it is also fine. Now we will go to this step where we are putting the value of x as L and 0. So at the first we have put x as L square minus L square sine 2n pi minus L square by 2. Okay, so minus L square by 2, and then the rest of the thing, I think, acha, then acha, we are in the track. Then it would have been L square by 2, and I'll just erase this formula once. You'll get this formula from any standard from internet also. So we are going to get 1 by L into, so rest we have cut this thing, you understood, right? Because why I have made this thing plus, earlier I have done this as a mistake because
Yes.
that minus sign was there. Now minus of minus will be plus here. So
Yeah.
anyway, so we are going to get L square by 2 from this side, and we are going to get L by 2. So what we got, that average or expectation value of position is L by 2. Interestingly, it is independent of n. That is the quantum number. So what I wanted to show, that for the quantum, the x, average value of x is independent of n. So for n is equal to 1, it is L by 2. For 2, it will be also L by 2. Right? You got my point here. Now we need to calculate for the square of this. So I will just go to the next uh, yeah, and I will do that x square. So it will be again, it will be a little bigger. Okay. And we'll do it for psi n is equal to 2, which is root over 2 by L sine 2 pi x by L. So I have, and now I am not doing for the n pi x by L because I remember that I think it is going to, so this x square may be dependent on, acha, let me do for n pi x by L only, then we will see if it is, we are doing the same thing or not. So please point out if I am making any mistake. Okay, 0 to L, 2 by L at first, and then it will be x square by x square sine square n pi x by L. So these are just trivial integration. The one means I also fumble in this kind of integration and I do mistake. And so this part of the quantum only require this integration skill or something like that. Today I'll also share some standard integral values that will be required for harmonic oscillator problems. So first we will do that. Again, we will using integration by parts. So here the thing is the integration will be much bigger because here x square term is there. So first it is sine square n pi x by L dx minus dx square by dx, which will be 2x, right? And then integration of again sine square n pi x by L dx. This bracket close and this first integration still holds, and then our third bracket close. So I'll write it in a smaller letter because we need some space. So the first integration will become x square. Acha, we'll again take these two inside, okay, two inside, and we'll have two in denominator, so it will become 1. So x square integration of 1 minus cos 2n pi x by L, same thing, just a bigger integration this time, minus 2x 1 minus cos 2n pi x by L, integration inside, and there is integration outside. And do not forget there is 0 is still there. 1 by L. So we'll quickly do this. X for 1 it is x, and it will be L by 2n pi sine 2n pi x by L minus. Now the problem is we are again getting back our this thing that x, x is still there, but the integration still hold that x. We'll get x from here minus cos 2n pi x by, I have done one mistake. I'll just erase some of the part. I will integration of this. So 2x is still there. I've just take the 2 outside of the integration x, and from the inner part of the integration we will get x minus, not minus because yes, minus because the sign won't change when we do the integration for that. You just get sine 2n pi x by L and L by 2n pi, right? Okay, and the last dx still holds. X square. Now it will become x cube minus L by 2n pi into sine 2n pi x by L minus, now interestingly it will become x square and x square dx plus uh, what we are going to do next, 2x 2 L by 2n pi. I hope you are following me. 2L by 2n pi.
Yes, the in the beginning, no, x cube. After that, it is minus l x square. It will be, no. We are multiplying the x square with the entire term, right?
Yes, yes, correct, correct.
So lx square upon 2n pi.
Yes, thank you very much. 12 by 2n pi into x into sine 2n pi x by L, and the dx is there. So we again have to do this uh, integration by parts for that part. So I can do this L by 0 for this for now, and we'll take it outside, right? Another just because we don't have to do any more integration for this part, right? So I'll just put the values of L and 0 so to make it shorter a little bit. And we can't forget that 1 by L is there, so it will be 2 by L, right? So 1 by L, L cube minus L cube by 2n pi. Again, sine 2n pi. So anyway, it is going to be 0, right? It is going to be 0 minus 0 cube minus 0. I'm not bothering about that much part. So it will be 2 by L. Now it is x square, so it will again become x cube by 3. And this part will be interesting because it is still 12 by 2n pi, and it will be x integral sine 2n pi x by L dx minus dx by x is 1 integration of sine 2n pi x by L dx bracket close, another dx is there and into 0. So I think how many brackets are there? 1 and 2 are open and I have closed only one. Sorry to use another bracket. So for this part, we can see that we are going to get only L square, right? The rest of the terms are 0. So we'll come back here 2 by L and then again x cube by 3 plus 2L by 2n pi. I could have cut these two also, but I'm still hopeful that something will come up. Now it will become x into uh, minus cos 2n pi x by L, and the L by 2n pi, the constant term, I'm writing it here. Okay. Okay. So this part is also I have done. Yes, x sin x, this part is done. And we are left with one more integral, last integral. That would have been L by, so L by 2n pi, because sine would have become minus cos 2n pi x by L dx and L to 0. Okay, I hope I am doing it correctly. L square minus 2 by L x cube by 3 plus 2L by 2n pi x minus x was 2n pi x by L into L by 2n pi plus 1 by L by 2n pi. My L and 1 are almost looking like the same. And cos, so again it will be square of this, right? Because now integration of cos is there and it will give me sine 2n pi x by L and bracket close L to 0. I hope I have not done mistake till now. I'll just put the values of L as x and y, right? L square minus 2 by L cube by 3 plus 2L by 2n pi minus L cos 2n pi into L by 2n pi plus L by 2n pi square sine 2n pi. That's good. Well, this whole term going to be 0 minus minus this this is 0 cube by 3, that will be 0. Then this 12 by 2n pi, I have taken the minus earlier, so I will not make any changes. So minus x, it will start with, so minus 0, so it will become minus 0 for the whole part. Then it is again, it will become sine 0, right? Because sine 0 is 0, so I will not bother about that. 0 0, this is, the whole part is gone to 0. Now this is 0. What else is there? This is 1. Okay, so I'll write it here, what I'm getting. L square minus 2 by L into L cube by 3 is remain, plus L by n by I'll write. And from here I am just getting just only one term, right? So this one term minus L square minus L square minus L square by 2n pi. Okay, so this is the only term I am getting from here. Minus L square by 2n pi. I hope I'm making it correct. L square, and now I'll just cut the L's, that it will become L square by 3. It will become, I will take it as minus 1 by n pi into L square by 2n pi. Oh my god, this is very big. L square minus 2 by 3 L square minus L square by 2n square pi square. I don't know if I have made it right. So can you check? I think Datta sir has already solved this thing. I think in his tutorial, right? Not tutorial, means in his lecture classes. I hope I'm making it correct. L square by 3 minus L square by 2n square pi square. So this is what we are getting for, this is what we are getting for this average value of x square. So, and we already got that x is L by 2. And I will just quickly. So, Priyanka, are you with me right now?
Yes, yes,
Yes.
yes.
So, can you find any mistake, or have I done it correctly? What do you think? Tina?
No, I'm not finding any mistakes.
Yes.
X square is L by 2 and
I just moved one blank slide here. So I'll just write what we got. We got x as L by 2 and x square as L square by 3 minus L square by 2n square pi square, right? Something like this we have got. L square by 2n square pi square. So for x square for n is equal to 2 state, it will be L square by 3 minus L square by 2 into 4 into pi square, which is L square by 3 minus L square by 8 pi square. So what we need to show is sigma x is equal to a by 4 pi, a by 4 pi into something is there 4 pi square, 4 pi square by 3 minus 2, 3 minus 2. Let's see if we are getting it, because I told you that sigma x is going to be root over x square minus x whole square. I hope so. It could be the either way around also. So root over uh, so right now it will be x square, right? Because then square of this L square by 3 minus L square by 8 pi square, 8 pi square minus L square by 4, right? So acha, so they have taken a, so we are taking L, so here the a is equivalent to L, okay, because their
Okay.
length is, so they have in Maclaurin Simons they have taken this. While solving our problem, I guess Sarah has taken the length of the box as L, so that is actually equal a or L. Okay, okay, let's see what else. So if we take L square as common inside the bracket, then what we got? 1 by 3 minus 1 by 8 pi square minus 1 by 4. And then we'll take it outside, L will come outside, and it will be, let us take um, this as 12. So 4 minus 3 minus 1 by 8 pi square, L into root over. So 1 by 3 minus 1 by 4, that is 4 minus 3 by 12, that is 1 by 12, minus 1 by 8 pi square. So can we manipulate something from there? Can we take 4 outside? That means 2 outside, that will be L by 2. So we have taken actually 1 by 3 minus 1 by 2 pi square. Okay, let's see what we are doing. So we just have to do, I think, some manipulation. 6 pi square as denominator, then we'll get something like 2 pi square here minus 2 pi square minus 3. I don't know if I'm making it correct. Okay, which is L by 2 pi, 2 pi square minus 3. Still 6 is still there, right? I hope you are following. L by 2 pi, 6 is still there, 2 pi square minus 3 is there. So I need it to become 4 pi. So I need to multiply the upper side with 2 also. That means it will become, inside it will become 8 pi square minus 12 by 6. Okay, that's good, I guess. So it becomes 4 pi square by 3 minus 2. Wow, that's a relief. Till now, I was thinking I'm making any mistake, but at least we have come to the solution. So, did you get it? What we have done here?
Yes, yes. We
What is
got the
the?
answer.
We got the answer at
Yeah.
last. Uh,
Yes.
so this is nothing. So there was nothing means very yeah, hard, right? Only the complicated integration and those calculation and some mathematical manipulation we have to do. Okay.
Yes.
Okay, so at least we have done this, and I hope you will be able to do this, right? If some question is given like this, I know in NPTL this only numerical question will be given, but it will be important in future also, right? For any other calculation. So we'll not bother about this, and let us go to the next question, which is a good question, I hope, because let's see. The question says. Many proteins contains metal porphyrin molecules, and this is actually a common structure of the porphyrin. Okay, so the general structure of the porphyrin molecule is given. Acha Priyanka, in which subject you have done your PhD, or means chemistry, biology, or something like that, or in chemistry itself?
Catalysis, chemistry only in catalysis.
Catalysis. So I hope you are very familiar with porphyrin, right? No,
No,
or biocatalysis or something like
I
that.
like it familiar, but yeah.
Yes. Okay. Okay. Anyway, so this molecule is actually planar, and it is already given the planar, and we can approximate the pi electrons as being confined inside a square. So whenever this thing a square is written, so I hope you will think it as a two-dimensional box, right? 2D box. So one with one along x and one along y. So there are right now two kind of restriction is there right now. Okay, so you have to think it as 2D box, a particle in a 2D box, and the particle is your electrons. Okay, so what are the energy levels? Acha, pi electrons being confined inside a square. What are the energy levels and degenerations of a particle in a square of side A? That is first question. And the second question is the porphyrin molecule has 18 pi electrons. You may argue that there are 26 pi electrons if you can see. Okay. So if you calculate like this one, I will start from here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11 pairs plus this 11, 12, 13, 14, 15, right? So I guess 30 pi electrons you can say. But actually the plane is this one. I'll just quickly remove those points. I'll just show you where the 18 pi electrons are there. So actually wherever I will draw this red thing inside that this this is actually planar structure wherever I am drawing this red thing. Okay. I was also confused why they are saying 18 because I am from a physical chemistry background. I thought why. So I checked the structure of porphyrin and find out yes, in the plane there are 18 pi electrons. So one pair from here, one, two, three, 4, 5, 6, 7, 8, and 9. So 9 pairs. Okay, 9 pairs of electrons are there, means 18 pi electrons total. So if we approximate the length of the molecule by 1000 picometer, then what is the predicted lowest energy absorption of porphyrin molecule? We'll come to it later. So first, let us remember what is wave function or the energy of a what is the energy value of a particle in a square box or the 2D box. So it will depend on both nx and ny. So let us first start with the uh, wave function. So it is actually going to be multiply of Lx into sine nx pi x by L and multiply of two one-dimensional problems, like one along x and one along y, sine ny pi y L y and Lx. Now if we are given, so this is for a rectangle. Now we take Lx is equal to Ly, then it will become square. So which is given here. So it will become 2 by L sine nx pi x L sine ny pi y by L. So for this problem, so it is always better to go back to the wave function and write for this problem. So the an energy value will be, so it will be us. So for wave function, it is always the product of two wave function, and energy is always the sum of two Hamiltonians, so the two energies in the each direction. So it will be nx square plus h cut s or h square 8 ml square, not h cut, only h, and plus ny square h square 8 ml square. So you can write it something like that, nx square plus ny square. We can take this thing as common, h square by 8 ml square, right? We take this as common. So up to this, I hope you are fine. Now, can you tell me that suppose 18 pi electrons are there? Okay. So what are the values of nx and ny? We have already discussed. It will start from 1 and it will be integers, right? So you can see your energy values could be 1 1, 1 2, E2 1. You got my point, what I'm trying to say? It could be 1 3, it could be 3 1, something like that. It can go along, right?
Yeah. Yes.
But for a square, means for a 2D square, you can see that energy of E11, the degeneracy is 1. Degeneracy means how many states are there with the same energy. If you see that there is only one, E11, it will have 2 H square by 8 ml square energy. But if you check for E12 and E21, they are going to have same energy. E13 and 31, they are going to have same energy because it is 1 square plus 3 square. Or for 31, it is 3 square plus 1 square.
Yes.
So they are going to be same. Similarly, it will go along E23, E3, 2, they will have same energy. So by this method, so they will have their energy states are there. Okay, so it will be something like this. So for E1, E11, so I will just write it in a, so energy will increase in this side, what I'm going to draw. And I will also write the energies. So it will be 2, and I will take this part as alpha. Okay, that means because this is going to be a constant. So I will not going to write it again and again. So 2 alpha, 1 square plus 1 square. Now it is E21 and E12, they are going to have same energy, which is 1 square plus 2 square, which is 5 alpha, right? Then 1 square and 3 square are 10 alpha. So that is, they are going to have again degeneracy 2. So this is E13, E31. So that is, they have the energy of 10 alpha. And then 2, 3 and 3, 2, they are also going to have same energies, right? Which is 2 square plus 3 square, which is 4 plus 9, which is I think 13 alpha, E23, E32, right? 3 square means 9 and yes, 13 alpha. But we also forget to write E22, which will have again one degeneracy of 1, and the energy is 2 square plus 2 square, which is 4 plus 4, 8. So it will come somewhere in between here, between 2 1 and 3 1. Say it will have E22, which have huge alpha, We can't forget this. We also can't forget E33. What will be the degeneracy? Only one. And the energy is 3 square plus 3 square, which is 18 alpha. So it will come somewhere after this. Okay. So we'll have again E33 somewhere here. I'll just write it here. 18 alpha. What about other energies? I am writing these many energy levels because again we need to find homolumo energy gaps. For that, first we have to put these 18 pi electrons in some energy states, and each energy state will contain two electrons just like an orbital. So see, if I start to put electrons here, it will look something like this. You remember these diagrams, right? So like MOT you can say. But those will come later. So one, so it will feel like this. Before 3 3, are there any 3 2 2 3? And then what are the other possibilities? E4 4 4 4. The energy again. This will have one degeneration. It will be 4 square plus 4 square, which is 32 alpha, I guess. And what about E4 1 and E1 4? They will have 4 square plus 1. So that is uh 16 17 alpha. So it will
Three
come.
E34 also, no? E34 and E43.
Yeah, the E43 will have energy. E43 or 34 will have energy 4 square plus 3 square, which is 25 alpha, right? So that is below 4 4, but still see 4 1 and 1 4, they will have energy 17 alpha. 4 square plus 1 or 1 square plus 4, that is 1 plus 16, that is 17. So it will come below this 3 3. So that is interesting because 4 1 has less energy than E3 144 because that has energy 17 alpha. Okay. So again, two electrons will come here, two electrons will come here. So how many electrons are still there? One, two, three, four, five, six, seven, eight. Eight means 16, eight pairs, 16 electrons. Now I have done one mistake. So I will just quickly erase that. The mistake is nothing but the filling of that electron. The states are all right. You remember Hund's rule, right? That will just have to fill it somewhere. The one electron here and same spin like this, right? And then we can fill these things. So these two will be unpaired, right? Are you getting my point?
Yes, yes, yes.
Yeah. Okay. So now see, now what are the things? So these are the energy levels we need to think about because now we understand the E41 and 14 our these are our homos. Homos means highest occupied molecular orbitals. Okay. Why I'm saying homos? Because there are two homos, right? Because 41 and 14. And E33 is our LUMO, lowest unoccupied. So So we have done with this first question. That what are the energy levels and degeneracies of a particle in a of side A? So we are now going with the side L. And the second question has that porphyrin molecule has 18 pi electrons. So we have filled the states with 18 pi electrons and we have taken care of the degeneracies, right? So now the question was that if we have to approximate the length of the molecule by 1000 picometer, length is this L. So then what is the predicted lowest energy absorption? Lowest energy absorption would be HOMO to LUMO, right? So the energy of E41 is 17 alpha and E33 is 9 plus 9 is 18 alpha. So 1, 2, 3, 4, 5, 6, 7, 8 and 9 pairs. So total 18 pairs are there. So these are your HOMO and this is your LUMO. So your energy gap delta E is 1 alpha. 1 alpha is nothing but A square by 8 ml square, right? Because alpha value we taken as alpha. This we taken as alpha. And we know that your energy difference will be equivalent to Hc by lambda, right? Because this is the light that will get absorbed so that your one electron from HOMO will go to LUMO, right? So that is your lowest energy absorption. So Hc by lambda will be H square by 8 ml square. So you need to calculate what is your lambda. Or in this case, the experimental value is 17,000 centimeter inverse. Centimeter inverse is a unit of wave number. Okay. So I generally remember it like that, that Hc by lambda is also, we can write Hc nu bar. So Hc cut. So 1 by lambda is your nu bar, right? So you need to calculate what is your 1 by lambda or nu bar, that is your nu bar. That would be Hh cut. So it will be H by 8 ml square C. Okay. It would be something like this, and let us calculate. I'll calculate in my phone. First I'll write the values. H is 6.626 into 10 to the power minus 34 joule second. The unit is very important. Now 8 into the mass of an electron is 9.11 into 10 to the power minus 31 kg. Then the length is already given, 1000 picometer. 1000 picometer means 10 to the power minus 12 meter. So 1000 picometer means 10 to the power minus 9 meter, right? Which is 1 nanometer, you can say. Picometer into 1000, that will be 10 to the power 9 minus 9. That, I hope that is correct. And square of that will be 10 to the power minus 18 meter square. And C is there. C is 3 into 10 to the power. So as centimeter unit is there, I will put it as in centimeter. You will understand why I am putting it in centimeter. 3 into 10 to the power 10 centimeter second inverse. Because this meter square and this joule thing is going to cut. I'll show you this. Your joule second unit is it. I have shown it earlier also, but see, joule is unit of power, right? So power is nothing but force into displacement. Force, unit of force is Newton, and unit of displacement is meter, and second is there. And Newton is now unit of force, and we know force is ma, mass into acceleration, right? So that is Newton is kg meter square, sorry, kg meter second minus 2 into meter into second. So your joule second is actually kg meter square second minus 1. Okay, so I'll just replace this thing just to simplify the units. So in physical chemistry, it is very required kg meter square second minus 1, which is the kg got cut, meter square got cut, second inverse got cut. See, the centimeter is there in the denominator and it will become centimeter inverse when you will do the rest of the calculation. So I'll just quickly calculate this thing in my phone calculator and let's see what value we'll get. 6.626 divided by 8 divided by 9.11 divided by 3 to 10 to the power minus 34 divided by 10 to the power 49 divided by 10 to the power 10. I'm making any mistake because I am getting some value around 3030.
I'll
3030.
just check on the calculator. On the mobile, it's difficult.
Yes, yes, yes. I think it is coming as 3030, right?
I just did without the no exponential term
Yeah.
0.3030.
So anyway, I guess it will coming means
0.0. Yeah.
because you see 10 to the minus 34 and 10 to the minus 31, it will become 10 to the minus 3, and here it is 10 to the minus 8. So 10 to the power 8, 10 to the power 8 into 10 to the power minus 3. So that is 10 to the power 5. And if you multiply that, you are going to get 3030 centimeter
3030. Yeah.
inverse.
Right.
Yes.
Correct.
So the thing is that the experimental value is 17,000 centimeter inverse. So maybe the mismatch is due to that, as we are predicting it as the 2D box, or means because these electrons, or these things out of the box, you can say, means out of, not out of the box, but out of the plane. So we are not considering these pi electrons, because we are considering only 18 pi electrons which are in a plane and are in conjugation. Okay, so that was, I think there was a one question in the assignment 2 or 3, that when we are going to see the the trend will be same. The trend was something like, it was said that if the conjugation increase, conjugation L is increased, then your energy, that is energy is, see, energy is inversely proportional to 1 by L square, right, for a particle in a box or 2D box. So the trend will be qualitative, trend will be followed, but your quantitative measurements will be wrong when it will be a long chain molecule, or there will be intramolecular, intra-electronic repulsion, something like that. And here, for this kind of problem, I think this porphyrin molecule has these 18 electrons are there in the plane, but these pi electrons are not in the plane. That is why this kind of, so obviously experimental value of the truth, 17,000 centimeter inverse. But if anyone is going to consider this as a 2D box, then the value is coming as 3030 centimeter inverse. Okay, you can always go back and check that if our energy levels are correct or not, but I think these are pretty much correct, because as you can see, we are giving the values here: 2 alpha, 5 alpha, 10 alpha. We have calculated that. We have found out the first step was that write the energy, what is the formula of energy. Then see that there are 18 pi electrons, so you have to fill at least 9 orbitals, right? So go for it. That put down or the here you don't have to think about it as orbital, but as energy state, which will consist 2 electrons per state. So you just feel that, and you will see the degeneracies and see that this thing will come, right? I hope this is and then this calculation will be helpful. Let we can go. Can I go to the next question?
Yes.
Okay. So this is one of the question that is almost similar to the rigid rotor problem. So the question says the Schrodinger equation for a particle of mass m constant to move on a circle of radius a is given. So we have to use this Schrodinger equation, which is minus h cut square by 2y d2 psi by d theta square equals to energy E psi of theta, and the theta is given that it will be in between 0 to 2 pi. That means your, so this is your ring or circle where your particle is moving along one center. And why instead of mass they have chosen I hope you have already seen the lectures of that rigid rotor. When we are considering these circular motions or this kind of motions, so we need to go back to, I mean, circular motions. In circular motion, your mass, your moment of inertia is equivalent to your mass. Okay, so you are going to see that your normally for 1D box, what you have chosen that your minus h square by 2m d2 psi by dx square, right? But
Yes.
as this is a circular motion, your mass is being
Inertia.
inertia is there, so that is the equivalent. So that is why that is your and there is no potential energy. That's why your uh, Schrodinger equation looks like that, and I hope at any certain point it will make some angle theta. That's why your theta is your variable here. So now the next point is written. So all the thing are already written. So where I is equals to ma square is the moment of inertia and theta is the angle that describes the positions of the particle around the ring. Show the direct substitution that the solution of this equation of this, actually this second order equation is a psi theta is equal to a I n theta. I hope you know this because you have already seen the how to solve the means particle in a box, right? For that we have got two linear combination: a sin x sin kx plus b sin uh, b cos kx, something like that, right? Here, if you, so they are show they want us to show that by direct substitution this is a solution, general solution. So you can put your psi theta is a e to the power I n theta in this equation, and you have to show that right hand side is equals to left hand side. Okay, so that you will be able to do easily because h cut square by 2i into d2 psi. So first, suppose you have done already once, that will be a I n e to the power I n theta That is already we have done one time. So this is your right hand side, minus h cut square by 2y, and you are going to do it again. But these are your constants, right? A, but in will come again. So it will be I square into n square into e to the power I n theta, which is your minus h cut square 2y a. Now I square is plus the minus 1 because minus minus it will be plus, and then n square is there, and e I n theta is there. So it will give you h cut square by 2I n square and a e to the power I n theta, which is your psi theta, right? So I just so by substitution you can see that this is your general solution. So so when you substitute this, you will see that your uh, E is that eigenvalue is actually coming as n square h cut square by 2y. That is what you have to show from here. Okay, that, uh, that you are going to get this. Use this to show this. So you are getting this n square h cut square by 2y. And now for this, you have already shown from the boundary condition for a rigid rotor that when you make an 360-degree rotation, you are coming to the same point again. Okay, so now psi theta to be single valued. So the important factor is here that single value, right? So it is the boundary condition here that at boundary means when it is coming back again after the 360 rotation, the value will be same. That psi of theta will be psi of theta plus 2 pi, right? So that is what they are saying, that if you use the boundary condition this psi theta is equal to psi theta plus 2 pi, you are going to get what you are going to get, that you are going to get whenever we are putting some boundary conditions, you are going to get the your quantum numbers, right? The quantum number arise from the boundary condition, not from the Schrodinger equation directly. I think this is discussed, right? A lot of time. So now let us write this. Psi theta is your a e to the power I n theta, and psi theta plus 2 pi is a e to the power I n theta plus 2 pi, right? So a e to the power I n theta into e to the power I n 2 pi, right? And a I n theta is there. So these things part. So you can see these to be true. So for this particular boundary condition, your I n 2 pi needs to be 1. And from Euler's theorem, you know that e to the power I theta can be written in terms of cos theta plus I sin theta, right? So you can write it cos I I to n pi, okay, plus imaginary I into sine 2n pi. So I have written I have done one mistake there. So I hope you got this is equal to 1. Now this part should be 0, right? 2n pi, because the I is there. If it is not 0, then your this part will always be there. So but you know your answer is 1. So there is no imaginary part. So this is going to be 0. So your n is integer. So this is 0. That means n is integer. Now you see if your n is 0, then your this equation resolves. If your n is plus 1, then it is resolved. If it is minus 1, positive or negative integer, it will be cos 2n pi will be 1, right? So from here you can see that the boundary condition will be, from boundary condition your quantum number arises to be plus 1 plus minus 2 like this. So this is just the same thing we are doing, we have done for the phi part of the rigid rotor, right? Because see, uh, what is the difference between the motion in a circle and the rigid rotor? Can you tell me? have you seen the lectures for the rigid rotor? Yeah.
Yes, yes, I have.
Yes. So can you tell me what is the difference between that particle, means it is rotating in a circle and a rigid rotor? Because you are
We
seeing that,
consider two masses when in a rigid rotor, like
but yes, but then again we converted it into
a
one
reduced
mass,
mass.
reduced mass to
Yes,
think it as a single or one body problem. From a two body problem, we made it a one body problem. So the difference is that there, if you remember, there are theta and phi dependent part. Okay, the rigid rotor R is constant. The radius of gyration, or if you think that the as it is called the rigid, right? Rigid. So the distance between two molecules or the radius of gyration is constant, but it can rotate it in the space anywhere it want. So the theta was from 0 to pi by 2, and phi was 0 to 2 pi, right? So you can think it like it is like it was like a uh, sphere kind of thing, if you can if you can imagine, right? For a rigid rotor. But see, for particle in a circle, that is only on two dimensional, means only slice of that, one slice of that. So if you so if I instead of theta, I would have gone for phi. So if I wrote for phi in these all these cases, so that would have been easier for you to tell that what was the difference, right? If I substitute theta as phi, then
yes,
you see that here this is only a slice of that sphere or the rigid rotor problem, that particle in a circle. Okay, so that's one thing. And what the last thing they want us to do is show that the normalization constant is 2 pi to the power minus half, and that you can do, I guess, because how can we do that? That we have to do 0 to 2 pi a square e to the power 2 I n theta d theta is equal to 0. Now what will be the value? A square will come here and 2 I n will be outside, not outside, but I guess 1 by 2 I n e to the power 2 I n theta, and theta will be from 2 pi to 0, which, and that will be 1, because this is I have written it wrong, sorry. So this would not be 0. The normalization condition is it will be equivalent to 1. So a square by 2 I n, that will become e to the power 2 I n theta, which is 4 pi, right? Here it is equal I 4 pi n. Okay, and minus e to the power 0, which is 1, equals to 1. Am I making I think I'm making it more difficult. Don't know. Let's see. Now, am I doing it correctly? Yes, I hope so.
there is theta, no? I 4 pi and theta.
No, the theta value is will go from 2 pi to
Okay,
0.
okay, okay, okay.
So
Yes,
you have
yes, yes, yes,
to do
yes,
that thing.
yes, yes, yes. Got it.
Now, now so these two things are different calculations. Okay. Now I have to go back to a square is equal to 2. Oh, I have made one big mistake. See, very big mistake. Can you tell me what is the mistake? I'll just go to the other. because I remember this is not a big, from the 5-part solution, if you remember, this is not a big thing. I'll just go to the next page and show you what mistake I've done. So this is always good to do 0 to 2 pi. The normalization constant is actually psi to the power, not to the power, psi complex conjugate of that, and this, then d theta, right? That is your integration, a normalization means yeah, condition. Now 0 to 2 pi, your psi theta is a e to the power I n theta. So psi complex conjugate of that is a e to the power I n theta, right? So I just have to write a from here and a square e to the power minus I n theta into e to the power I n theta, and the theta is equal to 1. And see, e to the power I n theta into e to the power I n theta to e to the power 0, that is 1. So a square 0 to 2 pi, the theta is 1, and your a is nothing but 1 by root 2 pi. Okay, so so that's how you already got the solution normalization constant for the rigid rotor also. Okay, I hope the mistake I have done, that I didn't took this complex conjugate, I made it square because I forgot that the complex conjugate I imaginary part is there. This is one more thing we all should remember. So this is a common mistake also that I have done. So this is one. So this problem is also solved. I hope you got the problem. Now the problem, how much time we have? We have some time. So this is another problem which I was talking at the beginning. That till now we are talking about the box that is starting from 0 to A, suppose. Instead of A, we are going to 0 to A. And we are saying that inside this box, the potential is 0 for a particle, and outside this box, the potential is infinite. So our particle cannot exist there. Okay, this is for a particle in a box. Now, the solution of this was, normalized solution was that 2 by A sine n pi x by A. This was the solution. And the energy was uh, n square h square 8 ml square. Okay. Now the problem says, what will happen if we take your boundaries from, so this is not up to the scale, okay? This is not up to the scale. So this is 0 minus a to plus a. Then will your wave function will change or your energy value will change? What do you think? So this is the whole question. I'm just stating in uh, maybe in fewer words. So for this particular problem, they want us to solve the particle in a box problem or get the wave function. So first thing what we usually do is write the Schrodinger equation, which is d2 psi x dx square plus this is for the, and we are forgetting minus a cut square by 2m. Your potential energy is 0, and it is equals to your E psi, right? E psi of x, and which is actually going to be as d2 psi. I will just make it fancier, that it is it, if we multiply both side by means if I take this thing to that side, it will be 2me by h cut square psi of x, and then we take it from this from right from we are taking it to the right hand side. So it will become plus, it will be 0. So the general solution for this, what we have written for this 0 to a, what we have written, we will write the same thing, because see, this is same, right? So we can take this also as k square, some constant. Okay, so then our equation become d2 psi by dx square plus k square psi. Here I am writing x, so I will write x here also, is 0. So for this second order differential equation, the general solution is a cos kx plus b sin kx. So this is what we have done earlier also, right? Now the problem comes because now the boundary has changed. Boundaries have changed, right? Earlier the boundary was 0 to a. So for that particular boundary condition, you got that. So what generally we do, that at the boundary the psi should be 0, right? Because outside the potential is infinite, so molecule would not be there. So at boundary it should be 0. So we will do the same thing as we have done earlier, that your psi at minus a will be equal to psi of a, which is actually equals to 0, right, at the boundary. Why? One thing, that outside the box that potential is infinite, so molecule won't be there, and to as it will be continuous, the wave function should be continuous at the boundary, right? Not at the boundary everywhere, it should be the continuous. So as outside the box psi is 0, so at boundary also your psi should be 0. So that is why I have written that psi of minus a equals to psi of a is equals to 0. I hope it will not create any doubt yet. So what we can write, a cos minus a, instead of x I am putting the value minus a, okay, plus b sin k minus k equals to 0 for this first condition, and for the second condition a cos k plus b sin k is also 0, right? So this we can also write a cos, you know that cos of minus theta is cos theta. So we'll write it like this, but b sine minus theta is minus sine theta, right? So we'll write that k is 0. So I'm getting two equations, 1 and 2. In one, the plus is also 0, and another minus is also 0, right? So if you do subtraction between 1 plus 2 or 1 minus 2, you will see, you will get two conditions. For 1 plus 2, you will get your a cos ka is 0, and if you do 1 minus 2, you will get a b sin ka 0. So do you have any doubt till now? Anyone?
No, 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 no.
Okay, okay. So if you do this like that, then you are going to get these
A
two.
cos of minus k is a cos k.
Yes, because cos of minus theta is cos theta. That is a trigonometric
Okay, okay.
entity we are using,
Yes.
and b minus
Minus
sine minus theta is minus sine
minus
theta.
sign theta.
Yes. So we are getting this kind of equation, that a cos k is also 0 and b sine k is also 0. So now see when this is possible. Now what is actually your k? Uh, Let me go back, that your energy values. I'll just write it here. Um, k is, k square is 2me by h cut square. So your energy is again k square h cut square by 2m, right? Now you can see from here that when your b sine ka is 0, when it is k is actually how can I write? I'll write it a little better way here because it doesn't look good. Sine k. Okay, I'll go back here a little later, but just from these boundary conditions, let us get that what is the value of k. K is wait, I have done no, I am making it correctly. Did I make any mistake here? Hmm. Okay, wait for a second. Let me check where have I done the mistake. You can see I have not done the mistake, but the thing is that if you see when is your cost function is going to be 0 and when your sine function is going to be 0. So see the general solution for these two, that your b sine k is going to be 0 and your a cos k is going to be 0. Can you tell me when this is going to be 0 for a, and what is the value of k for which these are going to satisfy? So that is actually going to be, see, your general solution for this is k is equal to n pi by 2. But this is, I am not finished yet because see what I am trying to say, 2n pi by 2a. Yes, 2n pi by 2a, because I will show you what I am trying to say. So this is the general solution for these two. See, when n is even, n is even means n is 0, n can't be 0, right? N is even means n is 2, 4, 5, 6, something like that. So let us take the condition for 2. So let us take k is equal to 2 pi by 2a. So if you put here b sine 2 pi, sorry, yes, 2 pi by 2a into a, you will going to get, you are going to get, let me write it here. You are going to b, if your n is even, b sine 2 pi a by 2a, right? But that is what I am saying. So your 2a cut, so you are going to get b sine pi, which is actually 0. If you take b sine 10, n is even, so I am writing 10 pi into a by 2a, you are going to get 5 pi, sine 5 pi, which is again 0. So see, for but for even values, of n, suppose n is 1, so b sine pi a by 2a, you are going to get b sine pi by 2. Sine pi by 2 is 1. So you are going to see that this is true. So k is equal to n by n pi by 2a is a general solution for this equation when n is even. And same thing you are going to see that when n is odd, then you are going to see that this a cos ka is going to be 0. Priyanka, did you get my point? What I am trying to say here? Any confusion anywhere? If it is from the start, I will start from again.
No, no, just here, the even in the odd part.
Okay,
Just
so
the last you were explaining, no?
you are all right up to a cos k is 0 and b sin k is 0.
Zero, yeah.
This part you are all right. So now see, we need to get some bound. So as we have put some boundary conditions, so we are going to get some quantization or something like that, right? As you have seen from the these many from particle in a box 3D or harmonic oscillator or something like this. So these many problems you have seen that whenever we put some boundary condition, we are going to get some general solution and we are going to get some quantized value of energy. Now the general solution for the, I will write it here. So the equations we got that a cos ka is 0 and we got b sin ka is 0. So I am saying that the general solution means the solution is common for both. Solution is for these two equation is k equals to n pi by 2a. Okay, so this is what I am saying. The solution of these two equation means solution means what, for what value of k sin k is going to be 0, right? For what value of k cos ka is going to 0. So that is what I am saying, that the value of k should be n pi by 2a. Now, now for even value of n, so this is true when n is even, and this is true when n is odd. I will show you an example. So n even means it could be 2, 4, 10, something like this. And odd means it could be 1, 3, 5, something like this, right? Are you with me till now? Or
Yes,
you
yes, yes,
okay,
yes.
okay. So now suppose you are taking 2, so b sine 2 pi by 2a into a is how much? B sine pi. What is the value of pi? Sine pi, that is 0. So it is going to be 0. Now instead of 2, you if you take 10 here, b sine 10 pi by 2a into a, you are going to get b sine 5 pi. Again, any n pi means for sine you are going to get it 0, right? So again you are going to get it 0. But this is not true. So b sine k will not be 0 when n is odd. That is what I'm saying. When n is even,
Yeah, got it,
this
sir.
is true. And when n is odd, the upper one is going to be true. Because cos pi by 2 or any integral of pi by 2, half integral of pi is going to be 0. That is what I am saying, that when n is odd, upper one is correct. When n is even, sine function is the your actual wave function. So that is what they are also saying, that the show, however, the wave function uh, for this case, that when it is from minus a to a, you are going to get psi n as both of these. That see, when n is even, you are going to get one sine function, and when n is odd, you are going to get cos function. So we are in the path. So that your what we got till now, that your k is n pi by 2a, and we also know that your k square is 2 me by h is h cut square, right? That we know. So your k square is here n square pi square 4a square into 2 me by h cut square. Uh, which is your in this is if we write it in terms of instead of h cut square, I'll write it h square and upper part will write 2 pi square, that is 4 pi square. So pi square is gone. What else is not there? Uh, so we got the energy value is going to be n square a square, n square a square, 8, 8 m a square into 4 is still there. That is n square a square. So see, earlier we used to get for particle in a box that 8 8 ml square, right? But for this case we got 32
32.
ml. So I'll come back to that the why we got that. But before that, let me give you the answers. What is that? Psi is psi of x or nx is a cos. This is what we got, right? N pi x, n pi x, uh, n pi by 2a into a, in which is n pi by 2a is 0, right? And b sine, because your solutions were uh, a cos kx plus b sine kx, right? So instead of so we are putting value of x there, a k there, okay? B sine n pi x by 2a 0 when n odd, and this is true for n even, okay? Because your general solution was a cos kx plus b sine kx. From there we got that your k should be n pi by 2a, okay? And for n odd value of n, you are going to get this, and for even value of n, you are going to get this. And if you do the normalization, same thing like the earlier, but here your limits are going to change, right? Minus a to a. Earlier for our problem, so means when you are going to do the normalization, that psi n star psi n dx is equal to 1 normalization condition. Just I am saying that now the boundaries are different. Okay, so let us do that as we are doing the for cos square theta. Means I'll not do this right now because I miss to discuss some more problems. I want to discuss some more problems. Just quickly, I'll telling you that. See, I hope you will be able to do this, right? Because there is no imaginary term, so again it will become a square cos square n
Cos
pi x
square.
by we just need to do that previous kind of integration what we have done earlier
Hmm.
in the first question, and we'll see that the value of normalization constant is going to come up like this 1 by root over a, something like this, okay, for both the cases. So the takeaway message from this question or this thing is that, see, your when we take 0 to a, so we used to get 1 by or sorry 2 by a sine n pi x by a, and now you are getting this with a different thing, but the main gist is that your wave function is still a sine function or a cosine function which changes it uh, periodically, okay, which changes the phase periodically. Means what I want you to say that when, so you see here what change we have made, that we have made a different boundary minus a to plus a. So what is the now the length? What is now the length? Now the length is a minus minus a, which is 2a, right? Are
Yes.
you with me?
Yes. 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 Yes.
Yes, yes. So if you consider a box of from 0 to 2a, what energy you would have got? The energy value you would have got n square h a square by 8m 2a square, right? If it have got from 0 to 2a, see, you are going to get the same energy value, that is n square a square by 32
32
m
MA
square,
square.
which we got right now
Mm.
for this problem also.
Yes.
Actually, the question says, does it bother you that the wave function seems to be dependent upon whether the walls are located at plus minus a or 0 and 2a? Because see, the particle really doesn't know where it is. We are just giving it the boundaries. So means what I am trying to say, you don't know what is actually is your origin is. You are just predicting here is your origin and here is your boundary. So the thing I'm telling you is that the wave function doesn't the wave function seems to change when you take different boundaries, but that is dependent on you. The particle doesn't know that if it is in between minus a or plus a or 0 to 2a. Okay, so the kind of coordinates we are going to take, okay, it will depend on that. So here we thought that your our origin is here. So means what I am trying to say, suppose where is my cursor? Um, yeah, okay, here is my cursor. So if I took minus a by 2 plus a by 2, so then again see it is going to give me some different normalization constant and different length, right? But if you check it that this is actually same, right? Because this is your 2a. Now let me take some different color. What I'm trying to say. See, this is actually your L now, right? L or if it is 0 to L, so now suppose your minus A to A is actually 2A. The length of the box is 2A. That is what I'm trying to say. See that it is still a sine or cosine functions, right? And it almost identical, right? N pi x by L it is, right? Or not? What do you think?
Yes. N by X by L.
Yes. So that is what I'm trying to say that the wave function doesn't really, the particle doesn't know that where it is. We are setting the coordinates and depending on that, you are going to get similar type of wave functions. Okay. And the last point they are trying to make that do you think that any experimentally observable properties depend on upon where you choose the origin of x-axis? What do you think? You see you have seen now the energy value is going to be the same where it is 0 to 2a or minus a to plus a. So energy is an observable property.
Yes.
So it is also true that your experimental observable properties are not going to change upon where you place your
Place
origin.
it.
Yes. Okay. So I hope this is an important. This was an important problem. Means as we are solving the Schrodinger equation, we should also know that the coordinate doesn't really play a much bigger role because particle doesn't know because it is a quantum mechanical particle. We also don't know that what is x because you are going to you have already seen the rigid rotor problems, right? So there that or hydrogen bonding hydrogen atom is already being discussed in the last lecture, I guess, last week of lectures. So there it was started with XYZ axis, but one doesn't know which exactly what is exactly the Z axis, which is the X axis or Z axis. We are just fixing one axis at Z, and after fixing that Z axis, we are getting okay. Perpendicular to that will be X axis, and here will be Y axis. But that is arbitrary, means that is up to us. Okay, that where we are putting our X axis or Z axis, something like that. Okay, I will not spend much more time here. I hope this is clear. Uh, should we solve this problem or we should stop? Um,
I'll just take a screenshot of the problem and try to solve it on my own.
sure, sure. I will anyway share these lecture notes.
Okay,
Yes,
okay.
so just take a screenshot anyway. It will
Yes, yes, yes,
be
I've taken up this problem. And the
okay.
next also, next problem.
Next problem is this. There are two problems here.
Okay, this is angular momentum, I think.
Yes, angular momentum. These are just calculation. These are not numerical problems or some concept is there that we can discuss tomorrow the next class, next session. And the next is some numerical problems from the rigid rotor problem.
Okay.
So this also comes as a molecular spectroscopy problem when it is actually infrared spectrum, IR spectrum, right?
Hmm.
So that is your vibrational frequency. Those kind of problems come in the molecular spectroscopy numericals also.
Okay.
Okay,
Yeah.
and this was again a very important thing because uh, you try to you don't have to remember anything. That's why I also can't remember. That's why I put this function. So for
For the
the
NPTEL exams, they're going to ask like this
no
because it
no
takes
no no not at all, not at all, not at all. I don't think so. I don't think so.
the problems which are given in assignment are like easier to solve. The
Yes,
ones which
yes.
we are solving now, it's little
Yes,
time
yes,
consuming.
yes, 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 yes. Means it is more like lengthier. Means
Lengthy. Yeah, yeah.
yes, written exam type, and that is like MCQ, right?
Yes, yes. So it will be more like MCQ.
And more like MCQ and MSQ, that multiple choice,
Okay.
not multiple, multiple correct answers would be there.
Okay.
But these are also important so that we can understand the
Yes,
subject better,
definitely.
right?
To understand the concept, yeah.
Yes, what are the integral? These are some standard integrals. Okay, so these was used, or we will be use this thing in a lot. So that's why I searched in the internet that this is an means so this part is the Gaussian part. Okay, this part is the Gaussian part,
Yeah.
and this integration is a standard integration of the Gaussian. How to do integration of the area under the curve of a Gaussian curve. So, we'll discuss it later anyway. You try to solve it because it is easier because you just need to do the integration. Here, nothing more is there, but just you need to means use this integral. Oh, I'll tell you one more thing that what does this double integral means? Double in, you know n integral n factorial means sorry not double integral double factorial. N factorial is n into n minus 1 like that you goes on, right?
Yes.
It
Yes,
is
yes.
going to 1. Now n double factorial is n into n minus 2, okay,
Okay.
into n minus
And
4,
four. Hmm.
and these it will go to 1 or something like that, depends, okay. So for 5 double factorial it is 5 into 3 into 1, okay, and for 4 double factorial what it will be 4 into 2, okay,
Okay,
it
okay.
is something like that, okay. So you try to do this, and I hope I have some more questions. Actually, I took a lot of time I think the first two questions itself. That's why I could not reach it. These are the two more questions, and then do I have more questions? I don't. So these are all the questions I intended to solve today, but I hope we will be able to solve it on the next day. And, I'll with those questions we'll discuss some more questions. Okay?
Okay,
And do
okay.
you have any doubts in the lectures? Any particular doubt?
No, right now I'm just watching the lectures. But once I try to revise and go through it, maybe then I'll have doubts. Right now it's just watching and writing down the notes, whatever is being discussed.
Okay, okay, sure, sure. Try to write them down and solve it yourself. Then I think that will be much more easier.
Yes. Huh?
Okay,
Yeah. Thank you.
okay, bye.
Thank you very much.
Okay,
Bye.
okay,
Good night.
okay. Good night.